Good evening, sir. I'm Ayush, and today I'm going to present a video on the topic steam turbine as a submission of my digital assignment 3. So, talking about the basic scenario of a turbine, the main purpose of a turbine is to generate electricity. So, the steam which comes from the boiler contains potential energy, which is then converted into further type of energies. So, this steam which comes from the boiler storing the potential energy is then passed through a nozzle which increases its pressure, and then this steam's potential energy is converted into kinetic energy, and then this kinetic energy possessed steam is passed to the runner blades of the runner which contains in the turbine, and then this rotates the runner with the help of that blades, and then this kinetic energy is converted into the rotational energy, and this rotational energy is then converted into mechanical energy, and in that runner, that is the blades containing the runner which is in the turbine, the shaft is connected with the runner. So, and then this shaft is again connected with a generator. So as the runner is rotating, it also rotates the shaft, and then this shaft is also getting rotated, and this is then converted into electrical energy from with the help of a generator. So we can say that the mechanical energy is now converted into electrical energy. So what is the working principle of a turbine? It is a fast moving fluid is made to fall on the blades of the turbine, and as the fluid strikes the blade, it rotates the runner. Here the energy of a fast moving fluid is converted into the rotational energy. And as we know, a generator is coupled with the shaft of the turbine. So this mechanical energy of the runner is then converted into the electrical energy with the help of a generator. So this is the basic diagram. As you can see here, that this is the boiler from where the steam is being generated and which contains the potential energy, and then this comes to the this is the steam which passes through the nozzle, and then it is a it generates a high pressure which is then passed to the turbine blade, and which rotates the blade, and then this is passed to the generator which finally generates the electricity. And the fluid the steam which needs to come out, so it comes out from this, and then a condenser is attached from which the steam is again condensed, and again it is used in the boiler to feed water, and again the cycle continues. So this is the basic cycle how a turbine, or how the basic functioning of electricity generation is working. Now this is the schematic of the runner which is in the turbine. These are the blades, and this is the runner. This is the nozzle from which the high pressure steam is coming, and this is rotating the runner. So from this we can conclude that there are basically 4 parts of the turbine. First is the nozzle, from where the low pressure steam is converted into high pressure steam. Actually the cross sectional area is very less, so more pressure is generated from the end of the nozzle. The second is the blade which rotates the runner. Third part is again the runner, and the last part is the casing on under which all the parts of that runner are safely kept protected. So these are the basic 4 parts of the turbine. So now I'll be discussing the types of steam turbine. There are totally 5 classification though. So the first classification is based on the mode of steam action. Under this it is divided into 2 types. First is the impulse turbine, and second is comes your reaction turbine. So what is the impulse turbine? If the steam available at the inlet possesses only kinetic energy, then it is known as the impulse turbine. And if the steam which is present at the inlet of the nozzle, contains both pressure as well as kinetic energy. Then it is known as the reaction steam turbine. Second classification is based on the direction of the steam flow. Under this comes two types, axial flow and the radial flow steam turbine. So the axial flow steam turbine, what it is, if the direction of the steam running through the runner is parallel to the axis of rotation, then it is known as axial flow turbine. And if the direction is perpendicular to the flow, perpendicular to the axis of rotation, then it is known as radial flow steam turbine. Here is a schematic of both of these turbines. So here in this figure we can see that the steam direction flowing through the runner is parallel to the axis of rotation. So this is known as the axial, and here in this figure we can see that the direction is perpendicular. So this was it. And third classification is based on the exhaust condition of the steam. Again, it is divided into two types, condensing turbine and non-condensing turbine. So what is condensing turbine? A turbine in which the steam is condensed and it is again reused in the cycle, it is known as condensing turbine. And in the non-condensing turbine, the remaining steam is directly passed in the atmosphere and it is not used again and again. So more output can be obtained from the condensing turbine. Fourth classification is based on the pressure of steam. Under this comes three categories, that is the low pressure turbine, high pressure turbine and the medium pressure turbine. In the low pressure turbine, the pressure ranges from 1.2 bar to 4 bar. In the medium pressure steam turbine, the pressure ranges from 2 bar to 40 bar. And in the high pressure turbine, the pressure is greater than 40 bar. And now comes the last classification, and that is based on the number of stages. So under this, they are classified into two types, single stage steam turbine and multi-stage steam turbine. So in single stage steam turbine, what happens is when the steam leaves the nozzle, it comes to the one end of the blade of the runner, and then after rotating it directly gets exhausted into the condenser chamber, and then again the cycle continues. But in case of the multi-stage steam turbine, after passing through the nozzle, it strikes the blade, impinges on the inner surface of the blade, and then again pass to the second blade, and it depends on the number of blades or the number of stages available. So accordingly, it is the steam gets circulated in the runner. So this was the main difference. So this was all about steam turbine. Thank you.